The logarithm of any number b to the base a is the index which the base must be raised to give the number. By definition, giving log b base a equal to c, this definition says that the b will be equal to the base exponent, the result of log b base a. Log b base a gave us c, so the base raised to the power the result, base a raised to the power our result c, is equal to the b, provided our base is not equal to 1 and the base a is what? Positive. Okay, so that's to say that if I have log m, then n base n equal to r, then by the definition the m is equal to my base n raised to the power the result r. Do you get that? So this, how do you get this? Write it here. Log c d equal to e. What will it be equal to? To be equal to c will be equal to my base, which is d raised to the power the result of the log c base d, and the result is what? E. Yeah, do you get that? Right. Now basically there are some things that we have to take note of the logs. We have to understand that the base of the logarithm can be written in any positive number except 1. That's why we are saying the a cannot be equal to 1. Also know that the logarithm of negative numbers do not exist, right? If we also write a log, say log b, and we don't see any base as we have here base a, then what it means is that our base is what? 10. So if you see any log without the base, then know that that log is in base 10. So from what we have seen from the definition, let's say I have log 2 16 equal to 4. Then from the definition, what it means is that 16 is equal to our base 2 raised to the power 4. And is that true? What's the meaning of 2 raised to the power 4? 2 raised to the power 4 means you're going to be multiplying 2 by itself how many times? 4 times, right? 1 2 3 4, and 2 times 2 is going to give us 4. 4 times 2 is going to be 8, and 8 times 2 is what? 16. So that is true, our definition is right. Okay, let us take some trials using the definition. Let's find log 232. So to find log 232 solution, we can let any variable be equal to log 32 base 2. So log 32 base 2. We can let it be equal to any variable, for instance y. So if that is the case, according to the definition says that the 32 should be equal to the base 2 raised to the power this result, y. Okay, and then if I have 32 is equal to 2 raised to the power y, then I need to do something to this 32 for it to have the same base as 2, so that I can equate the exponents to get a value for y. Then I ask myself, 2 raised to the power what is going to give me 32? So we just saw that 2 raised to the power 4 gave us 16, right? Then let us check 2 raised to the power 5. 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. So let us do the multiplication. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. Then it means that in place of 32, 2 raised to the power y, which is equal to 32, you can write 2 raised to the power 5 in place of its 32. Now looking at 2 raised to the power y equal to 2 raised to the power 5, we have an exponential equations of the same basis, and according to exponential equations, if your bases are the same, I can equate the exponent. Therefore, I can say y is equal to what? 5. This, hence, log 32 base 2 is equal to 5. Yeah, so by the definition, we have been able to find log 32 base 2. Let us try another one. Let's try another one. Find log 8. Okay, let us find 9 log 27 base 9. Log 27 base 9. So, just as we did initially, we have to equate our log 27 base 9 to be equal to any variable of our choice. So this time around, let us use the variable x. And doing that, by the definition, then we can say that 9 raised to the power x, our base raised to the power the result, is going to be 27. Okay, going to be 27. Now having that, then we have to look for a scenario where the basis of our exponential equation becomes the same. And I think the common basis for 9 and the 27 is going to be, common base is going to be 3, right? So we need to change this 9 to base 3. But we know that 3 raised to the power 2 is going to give us 9, and 3 raised to the power 3 is going to give us 27, right? So in place of 9, you're going to write 3 raised to the power 2, then by the x, okay? And then here we're going to have 3 raised to the power 3. Now looking here, you see that the bases of our exponential equations are the same. Then we can equate the exponents. So the exponent of this is 2x, and the exponent of the other one is 3. You're looking for the x, right? You're solving for the x. Then I'm going to make x the subject by dividing both sides of the equation by the coefficient of x, which is 2. And then doing that, my x will be equal to 3 over 2. and I can therefore conclude that log 27 base 9 is equal to 3/2. Right, if you find this video interesting, you subscribe to the channel for more of such. See you when I